In this video, we are going to begin looking at the review for Exam 3. So looking at number 1, it says determine whether each distribution represents a probability distribution. If it does not, state why. Remember, for a distribution to be a probability distribution, the first thing is the probabilities themselves must add up to 1. They must also satisfy the rules that state probabilities must be between 0 and 1. So you can't have a negative probability, you can't have anything outside of a 1 probability, greater than 1 probability. It doesn't matter what your x values are. They can be negative, they can be positive, they can be 0, anything like that, because those are your possible outcomes. So in other words, I may lose money on a deal. That's a negative x value. But a probability still has to be between 0 and 1. So if I look at this first one, this has a negative. So this is not a probability distribution because of the negative. Now looking at the second one, okay, they're all positive, they're all less than 1. So then we need to add them up, and these add up to 1.0. So yes, it is a probability distribution. Now the third one, looking at this, okay, they're all between 0 and 1. That's a good start. So then we add them up, and when we add them up, they actually only come to 0.75. So it doesn't add up to a 1. So we're missing some values here. So this is not a probability distribution because it does not add up to 1. Now on the last one, they're all between 0 and 1, which is good. And then when we start to add them up, we add up to 1. So yes, this last one is a probability distribution. Again, you must remember that probability distributions, the probabilities themselves have to add up to 1. Going along with those same lines, we want to fill in the missing value so that the following tables represent a probability distribution. So in order for it to represent a probability distributions, the probabilities must be between 0 and 1, and they must add up to 1. So notice on this first one, these are negatives. That's okay. These are the x's. These are the possible outcomes. It's the probability of x that we have to look at. So in order to find the missing number, what we're going to do is we're going to add up these three, 0.05 plus a 0.47 plus a 0.32, and that's going to give me a 0.84. Now they have to add up to 1, so I'm going to subtract the 0.84 from 1, and I'm going to get a 0.16. That is the probability for 0 in this particular case. We're going to do the same thing for these others. We're going to say 0.3 plus a 0.15 plus 0.25, and that's going to add up to a 0.7. Well, 1 minus 0.7 is equal to a 0.3. So this is a 0.3. And then on the last one, 0.3 plus 0.3 plus 0.2, that's a 0.8. 1 minus 0.8 is a 0.2. Because all of these values in each column must add up to 1. Now, the following table represents a probability distribution of the number of vacations, x, taken last year for a randomly chosen family. So this row represents the number of vacations, 0, 1, 2, 3, and 4, for each family. There's a probability that a family took 0 vacations, 0.15. 1 vacation was 0.56, and so forth. Now, just to make sure, check it. make sure that all of these, what these add up to be, 0.15 plus 0.56 plus 0.15 plus 1 plus 0.04 adds up to 1.0. So our probabilities add up to 1. They're all between 0 and 1. So it does make a probability distribution. We want to find the mean and the standard deviation. Well, in order to find the mean, what we're going to do is we're going to take each x value and multiply it by its probability, and we're going to add each of those up. This looks like 0 times a 0.15 plus, because we're going to add these up, 1 times a 0.56 plus 2 times a 0.15 plus 3 times a 0.10 plus 4 times a 0.04. So 0 times anything is 0. 1 times anything is itself. 2 times 0.15 is 0.30. 3 times 0.10 is a 0.30. And 4 times a 0.04 is a 0.16. Add these up, and we get 1.32. So the mean is 1.32 vacations. Now I'm going to draw a line here, because now we want to find the standard deviation. In order to find the standard deviation, we must first find the variance. Recall back from chapter 3 when we had the value minus the mean, and the value minus the mean squared. We're going to do the same type of process here, except we're going to add a last column, the value minus the mean squared times its probability. And we're going to do this for each of the values. So we have 0, 1, 2, 3, and 4. 0 minus 1.32 is going to give me a negative 1.32. Negative 1.32 squared is going to give me a 1.7424. I'm going to take that 1.7424 and I'm going to multiply it by the probability of 0, which is 0.15. That's going to equal a 0.26136. So I finished that row. I'm going to do the exact same thing for all of the other rows. So 1 minus 1.32 is going to be a negative 0.32. Negative 0.32 squared is going to be a 0.1024. Now you'll notice that I'm putting these values in parentheses and then squaring them, which is the exact same thing as up here. I want this entire thing squared, so negative times negative gives me a positive. This column must always be positive, which means that this column is always positive. Okay, so I'm going to have 0.1024 times a 0.56, which is going to equal to a 0.057344. Then we're going to take 2 minus 1.32, gives us a 0.68. 0.68 squared is going to give us a 0.4624. 0.4624 times a 0.15 is going to give us a 0.06936. 3 minus 1.32 is going to give me a 1.68. 1.68 squared is going to be a 2.8224. 2.8224 times the probability of 3, which is 0.1, is going to be 0.06936. 2.28224. 4 minus 1.32 is a 2.68. 2.68 squared is going to be a 7.1824. 7.1824 times its probability of 0.04 is going to equal 0.287296. This is the chart in order to get us our variance and standard deviation. Now recall back in chapter 3, whenever we were finding the variance, we did this column, we added it up, and then we divided by how many numbers there were. Well, in this case, that's kind of already been done for us with the probabilities. So whenever we look for the variance, sigma squared, it's just going to be the sum of the value minus its mean squared times the probability. So we're literally just going to add up these values right here. We do not do any other division. Okay? So whenever we add up all of these 5 values here, we end up with a 0.9576. This is our variance. So this is the variance. Our standard deviation, of course, is the square root of that variance. So we take the square root of 0.9576, and so we get 0.97857. This is the standard deviation of these values of this particular probability distribution. Let's go ahead and look at parts B and C. Find the probability of a family taking more than one vacation. More than one indicates 2, 3, or 4. So if we look at this chart, 2, 3, or 4, we're going to add those values up. And so we're going to get, let me go back here, we're going to get a 0.15 plus a 0.10 plus a 0.04. Add this up and it's going to be 0.29. So the probability of a family taking more than one vacation is 0.29. So the probability of a family taking more than one vacation is 0.29. Part C asks us to find the probability of a family taking 2 or fewer vacations. So that's going to include 2, 1, or 0. When we look at those probabilities, 2, 1, or 0, that's going to say that we want to add up 0.15 plus a 0.56 plus a 0.15. And that's going to give us 0.86. So the probability of a family taking 2 or fewer vacations is 0.86. So again, the probability of a family taking 2 or fewer vacations is 0.86. So go ahead and try some of the others, and then in the next videos we will look at some of the other questions to this review.